Have you ever wondered if learning a new skill could physically change your brain? Well, in 2004, a researcher named Draganski embarked on a mission to explore whether mastering the art of juggling could actually change the brain physically. Here's how they did it. They gathered 24 eager participants, all of whom had zero juggling skills, and divided them into two groups. Before they did anything, they all did MRIs to get baseline measures of their brains. Then one group became the juggling experts. They learned how to juggle over the course of 3 months, spending an average of 30 minutes per day perfecting their juggling skills. The other group, the control, just continued with their daily lives. Then both groups did another round of MRI scans. And what did these MRI scans reveal? Amazingly, the juggling group showed growth in gray matter volume in the mid-temporal area, a brain region associated with spatial awareness and motor skills. Their brains had physically changed as a result of their juggling behavior. This is strong evidence showing how neuroplasticity can affect our brains. But here's where it gets really intriguing. These structural brain changes weren't set in stone. When the juggling group put their juggling balls down for a 3-month hiatus, the newly formed gray matter began to fade away. This process was the result of neural pruning. Neural pruning is our brain's way of getting rid of neurons that it doesn't use. So the phrase use it or lose it applies quite literally when it comes to our brains. Draganski's study was a groundbreaking demonstration of neuroplasticity, but there are a few things to keep in mind. First, let's look at the strengths of the study. The study used a pre-test, post-test design, which did a good job of showing how neural density changed over time. And the second strength was that the study was experimental, which helps us argue for a cause and effect relationship between behaviors and changes in the brain. Now let's look at some issues that the study had. First of all, the sample size was pretty small, so the results could have just been a result of randomness. And the second issue with the study was that it's a field experiment. So the changes in the brain could have been the result of some other factor in the people's lives. Okay, so that's an overview of Draganski's 2004 study of neuroplasticity.